At Optimal Energy, we know that solar power is not always available when the customer needs it the most. Energy storage is then offered to customers to help alleviate this problem. During our customer discovery, we found that operation managers in the basic metal industry are currently struggling with this problem. They have very high demand rates, and because of their near non-stop operations, they struggle to reduce this cost. Unfortunately, they are not satisfied with solar plus storage solutions that have been offered before. Thanks to the high cost of batteries per kilowatt per hour, competitors in the market are struggling to get to these customers. Operation managers want to reduce their demand charges but don't want to purchase a product with a break-even period that is longer than 3 years. Efficient storage size can help address this problem, but it is not enough to remedy this problem. That is why our solution is split into two parts, sizing and power management. To start, our patented power management algorithm is made up of 2 layers that work in tandem together. The first layer creates a long-term operational strategy for the battery. This layer takes system and environmental inputs such as load, PV power generation, cost of electricity, battery SOC, and weather information. This layer uses this information to generate a dynamic model of the system and forecast the energy needs of the site over the time horizon. A battery operation strategy is then generated by optimizing the electricity bill dollar amount and the battery degradation. This battery strategy is then sent to the second layer of our algorithm. Our second layer is responsible for the real-time operation of the system. It takes in the same inputs as the first layer as well as the long-term operational plan. Just like the first layer, this one also generates its own dynamic model and optimizes the electricity bill dollar amount. The main difference is the first layer operates on a long-term time horizon while the second layer operates on a very short time horizon. The final output of this layer is the power command that goes out to the battery inverter. This can be seen in the demonstration. This process allows the second layer to check if the first layer's long-term strategy for how the battery should be used is truly the most viable solution and allows for it to make corrections in real time as actual events occur. During our initial test with an interested customer, we found that our software can reduce electricity costs by 15% more than peak shaving algorithms. Our sizing software creates a dynamic model of their site by using a wide variety of information like their electricity rates, PV size, and historical load data. What makes our sizing stand out is that we are using very similar optimization modules as our power management software's first layer. By essentially using our operational method to do the sizing process, we are able to accomplish a smaller size for the energy storage system. During Ready, our company has progressed in both the technical and the business side. During our customer discovery, we learned that the current language the code is in does not scale well and has complications when installing it into a controller. We have been converting our MVP into an open source language that is cheaper to commercialize and scale. On the business side, we have built strong connections with our partners at California State University, Los Angeles, the Los Angeles Department of Water and Power, Southern California Edison, and the California Metals Coalition. These connections give our company access to a fully equipped power laboratory and different avenues to reach out to our potential customers. We are also getting the continued support from the University of Arizona Center for Innovation and New Energy Nexus to find EPC companies to partner with. Most important of all, a provisional patent has been submitted by the inventors of the IP. After seeing the market opportunities of this IP, the inventors established Optimal Energy and have signed a licensing agreement that makes Optimal Energy the sole licensee of this IP. The American-made network is helping to facilitate this process through their power connections in BAT's Calend. From our customer discovery and with the help from the market researchers at Dawnbreaker, we found that a new market exists for solar plus storage power management technologies for basic metal industry plants. We then validated a serviceable market for basic metal plants to be $164 million, and we aim to capture $8.2 million of this. We plan to find a total available market through continued customer discovery. We learned that operations managers at metal plants are looking for a complete solution for their power needs, and when they look for these solutions, they turn to their trade organizations, their utilities energy advisors, and look for word-of-mouth recommendations from others in the industry. That is why we plan on capturing this market by using our connections with the California Metals Coalition and the local utilities to facilitate pilot projects that will showcase the strength of our MVP. From there, we will partner with EPC companies to more easily provide a full solution by demonstrating the value of our software. The Optimal Energy team is well suited to take advantage of this market opportunity. Our primary team is made up of electrical engineers with backgrounds in power, renewable energy, and energy storage and have been deeply involved in the creation of the IP. We also have the support of our consultants to guide us in the development of our MVP and to help in the commercialization process. The next step for Optimal Energy is to complete the translation of the IP into an open source format so that the software is market ready. We plan to use the prize money to pay our employees to complete the translation process of our MVP, continue the refinement of our MVP's AI, and to develop an API for our software. All this will put our MVP into a market-ready state that can be installed into our controllers and can then easily interface with the battery inverter.